All right. You said I should slow down, so I'm going to do that right now. I always like to share my screen, and I always like to pick from existing drawing. It makes my work much more easier and faster. Instead of creating all of these things 100% from AutoCAD, it's going to take you a very long time to achieve. Okay, so if I click on viewports here, I'll click on 2 vertical. Okay, so I already have some existing drawings on my software in AutoCAD rather. Okay, so if you can remember from the design, it tells us that the width of that base is 1000 by 1000 is a square base, and then the depth of that base is 500, assuming is perfectly okay, safe, and economical. Okay, then I just want to trim this. It's just a normal trim, just the normal AutoCAD tool. I have not even started the main structural detailing yet. All I'm doing here is just to trim this to make it look okay. So this is just the normal trim tool. I believe you are familiar with this. So here now I'm going to use my grid lines. Very important, very, very important. And again, like I said, I already have an existing template here. I will just match property, okay? I just want it to look just as the way this one is. So I wouldn't want to, okay, so you can see what I have here. I'll match property with this and every other line inside. Please, I have not even started any reasonable thing yet. I'm just trying to make this look like the one I already have that is existing. Okay, so I'm just matching this property. Okay, then I'm going to insert my grid lines. So O for offset, enter 115, because the thickness of this wall is 230. So 115 would be the center. So I will just do that quickly. So I'll also match property. So you don't have to do it exactly the way I'm doing it right now. Like I said, I have not started the major detailing yet. So I'm just arranging this. So yours must not be exactly like the way I did mine. You can play around with the type of lines, the type of thickness of your lines. You can play around to whatever you feel actually suits you. Okay, so I just like to present my detailing this way. So it's not a fixed rule that you must do your own like this. Another thing, you must always confirm the entire length of the building. Okay, so this is not up to 30 meters. Okay, once your building gets to 30 meters, it is advisable you introduce an expansion joint. Okay, once it gets to 30 meters and more than, you introduce an expansion joint. But I think I was told that it has changed to 40 meters now. I have not confirmed, but we used to use 30 meters. So if you use it as 30 meters, it still makes your building more safer, okay? It's still safe, it's safe and more safer, okay? So, but here it's not up to that. So we are not going to be using an expansion joint here. Okay. So, but then I stand to be corrected anyway. That is why I will encourage you to lay your hands on RCD, Reinforced Concrete Design book by Victor Yenuga. Please lay your hands on that book. If possible, try as much as possible to learn RCD 2000 by Victor Yenuga. It's very, very important. It's an eye opener. It will give you a deeper insight of design. Honestly, trust me. To give you a deeper insight of design, a more deeper insight of design, because right now we are just doing detailing. So that one will open your eye more, so you'll be able to understand design properly. So I want to extend all these my grid lines to these boundaries. Okay, that is why I created this. So like I said, you must not follow whatever I'm following my pattern. So this is actually how I like to represent mine. So it depends on you. So it's not fixed. Just want to bring out my grid lines. So today we'll be focusing more on the foundation. Then in our next class, we'll go into another structural member. And we're using a pad foundation, a combined, yeah, just a pad, and then we'll definitely have those strips around them. Okay. So here now I have an existing column. From the design, I used a 230 by 230 size of column. Okay. So, and it was safe. Everything passed. Okay. So, but you can confirm it. You can see this is the design. This is the detailed drawing that was generated from the design in Prota Detail. Okay. So this is the detailing. The design was done in Prota structure. So this is the detailing. All the columns are 230 by 230 size of column. And that is what I intend to maintain. So I'll come back to my AutoCAD. And then if you measure this column here that I have that is already existing, it's 230. You can see it's 230 by 230. So instead of creating a whole new column, it's better I just copy from an existing drawing that is already the same. So I'll paste them along where I think I should be having a column. So let's come here now. Let me show you the architectural drawing. And then let me come here. This is the ground floor level in the architectural drawing. So you can see around where I have my walls, around here, you can see I'm placing columns here, here, here. I'm not placing any column at this point because this span is actually not large. You can see this is 2,730. So I'm just placing columns there. In order for you to understand where you are supposed to introduce a column whenever the span is getting to or is becoming wider, where you are supposed to introduce a column, please, I will encourage you. I'm still emphasizing on that book. Please lay your hands on that book to have a deeper insight. Okay, so you'll be able to know when it's becoming larger, when the span is becoming larger, when to increase the thickness of your beam, when to increase the size of your column. Okay, so there are rules to all of this. Okay. But right now, based on what we have, I can tell you that the size of 230 by 230 will serve, and based on what the software has given us as in our design. Okay, so this one here, already the architects placed these columns as 230 by 230. So but I'm going to maintain my own column. I'm going to delete the ones from. Please just send me a message on WhatsApp if you can hear me. You are not seeing my screen. Okay. Okay. All right. Can you see my screen now? Please, I need you to respond quickly. Response, please. Can you see my screen now? Send me a message on WhatsApp. Are you seeing my screen? All right. So I have not done anything much on this. By the way, I think I'm recording this already. Yeah, I'm recording it. So you can go through it again over after the recording. So it's just the columns that was given to me by the architect. I just took them out and I'm placing mine, but in the same position, and it's also the same size of column. Okay, the same position, no difference with the former one. Okay. So I have already analyzed this building and designed it already in Pruta structure. So based on the positioning, where I'm positioning all of these columns right now, I have already done the design and it was safe. Okay. So I have a full assurance that this design is safe based on the analysis and the design that has been done already using Pruta structure. Mind you, there are so many other softwares you can use to analyze and do your design. You can use RCD 2000 to even analyze, do your design with that RCD 2000 by Victor Oyenuga. Okay. It's very, very good. I always encourage people, most especially beginners, to start with RCD 2000. It's very, very important. Very, very important. I have been emphasizing on it. Okay. Very, very important. Is an eye opener. It will open your eye to the reality of design. Okay. All right. So this is staircase area. All right. Now, the next thing I'm going to place is my base. Okay. So I'll copy this. Now, you know the base size that was given to us by that software is 1000 by 1000. So I think this one is 1200. Okay, yeah, this is 1200. So to do this now, let me offset 500. I'm going to make this base smaller. Okay. All right. Okay, so we can see this is what we have now. Now, all the bays are actually similar. All of them are similar. The one thing about Prota structure is that it will give you a different name for each of them. Okay, but you know, you can group them when you have similar kind of base, you can group them even in Prota structure. So you can actually do a grouping whereby all the similar base. But in this design, all the bays are actually similar. They have the same size of base, the same depth of base, and then based on our reports. So all of them are similar. Instead of giving them a different name, even the columns, they are all similar. Even though some of them are carrying different loads. Like this column now is definitely carrying a different load from this column. This column is definitely carrying a different load from this column. Okay, you must know we have axially loaded columns, we have biaxially loaded columns, and then we have the uniaxially loaded columns. Please, I encourage you, please, you must lay your hand on RCD 2000. Get RCD 2000, get reinforced concrete, simplified reinforced concrete book by Victor Yenuga. It's very, very important. It's going to open your eyes to all these things I'm actually saying right now. Structural design is very, very deep. It's not just a drawing. Okay, it's not just a drawing. All right, so this is it. If I copy this, I copy this. Now, these columns, like I said, they are carrying different loads. Okay, they are actually carrying different kind of loads. So they are not the same. But I can tell you that this column and this column is actually the same based on the span here and based on what you have as the span here. Okay, so they are definitely carrying the same kind of load, so they are the same. But in this design, because based on your design, by the time you run your analysis, we did our analysis, we discovered that all these columns are carrying the same diameter of reinforcement, the same spacing of links, the same size of links. So there's no need of we giving them a different name, because the reinforcement that was provided for them, even though they are different loadings, they do not vary that much. So in that case, we are going to give them one name. Okay, that is if you are doing your detailing manually using AutoCAD. But if we were to maintain the one from Prota Detail, you are definitely going to see it as different names. All right, let me show you an example of what I'm trying to talk about. So you can see all these columns, all of them from Prota Detail, everything, they are the same, 4Y16, 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 even though they have different names. This is 1C22, 1C21, 1C20, but they have the same size of reinforcement. Okay, even their links are actually the same. So even though they have different name, and they are in a different position, and they are carrying different kinds of loadings, because their loadings are not the same. Okay, but in that case, since all of them are the same, okay, the reinforcement that was provided, the size of the links, everything is the same, there's no need of us giving them a different name. So we can just pick one single name for them all. That is why I said it's deep. Okay, in Prota structure, you can see it's giving you different names for each columns. Although you can group, there's a way you can group in Prota structure where you group your structural members that are similar. So when you have similar columns, you can just group them, and then it will arrange itself based on that. Okay, so if you want, I believe you understand what I'm trying to talk about. So if that is correct, I am definitely going to give all of these the same name. So there's no need of me saying 1C1, 1C2, 1C3, and all that. So I'm going to maintain the same name for them all. So it's the same base, the same size of base, the same size of column. So there's no difference all through. So that means I'm providing the same type of column for the entire columns in the building. I'm providing the same size of base for the entire base in the building. But a disclaimer, please. It's not in every building you find that. In some buildings, you can have different types of columns. There are buildings that you have maybe a circular column, you have a column in trapezoidal shape, you have columns, you know, circular columns, rectangular columns, square columns. So they cannot have the same name. Okay? Because they are different types of columns. So in that case, they are going to be different. So it's wide. Please get the book. There are sample detailed drawings in that book as well. You have sample detailed drawings in it. A lot of it. He took, I think, a practical design and he did the analysis. He did the design. Then he did the detailing. There, everything is inside that particular book, the latest edition right now. I think even the old one has that. Okay. So please try as much as possible to lay your hands on it. So you can see I have position on my columns in their positions and their base as well. So another thing I'm going to show is the trench, because we are definitely going to dig to put our walls, okay, in our substructure. So there is this tool they call multi-line, ML for multi-line. I'll press enter. I'll press J to justify. I'll press Z for 0. Then I'll press S for scale. Then I will type 670. Or I will tell you where that 670 is coming from. I think, is it 670 or 690? Sorry, please let me confirm that. So it's ×3 the width of your wall. So let's confirm that, please. Calculator. 230 multiplied by 3. Okay, it's 690. Sorry. J, enter. Z is already set in my computer, but you know, for this purpose of this class, that's why I'm taking it over again. Normally, if I type ML, it will just give me and that thickness without me following this process anymore. I will drop and I will pick. So this is actually going to be our foundation layout. Our foundation layout. These are all where we are actually going to dig. We are digging this area, the width of 230, 690. So you know you are going to have your walls at the center of that 690. So when you go to site, this is actually what you find. Okay. Okay. So ML, enter. These are just the trench. All right, so these are our trench. So you do it for everywhere you know you are going to dig. We're digging all of this. That's live on site, okay? This you dig all these places on site. So you can do it for everywhere, okay? Because of our time, I may not capture everywhere. Okay, so you put in your trench everywhere, and then you have your BRC mesh. Okay, BRC mesh also comes in different sizes. Okay, so I'm going to adopt this one as my mesh that I'm going to use at the ground floor. Okay. All right. So this is the mesh I'm going to use. Okay. So right now I am actually done with my foundation layout. So you can impute the dimension everywhere where you are supposed to have your dimension. Okay. You can put your dimension. Make sure you dimension it. Very important when they are actually doing the setting out. They will definitely use this for the foundation layout. So make sure you specify, you put in the dimensions at the right places that you are supposed to have your dimension. Okay, so you dimension here, dimension all of this, dimension all of this here as well. Okay, having done that, you have to take a cross section to show the depth of that foundation and then the width of that strip. Okay, so you specify that the width of your trench, the depth of the foundation. Okay, cross section 2 will give us an L shape. So if you take, so I have just 10 minutes more for this to end. So let's say I take this from here. You know, this one comes this way. This is an L shape. This is a typical example of how that cross section here look like. Don't worry, I will explain that. And then this one for T. So this is not drawn to scale. Okay, I already have a sample existing here. Instead of creating this from scratch, I will just pick from an existing drawing. Because if you check, their cross section are most likely going to be the same. The only thing is maybe the thickness of the base, then the way, most likely the thickness of that base. Yeah, that's the basic difference. Then probably the depth of the foundation may vary, and then you specify all that in your cross section. Okay, so this is already an existing cross section of this base, so there's no need for me to create this all over. The only thing is I'm going to explain that quickly for you. Here I used to have one that has all the detailing here. All right, good. Now you can see the 150 here is the concrete floor slab. Okay, that's what they call the common name we call it here is German floor. Okay, so that is that. Then here, you know, you have your backfill here. Okay, then you may have the hardcore, and then on that hardcore you have then you have your hardcore probably around here. Then you cast your concrete. Okay, so well, not every engineers use that hardcore in their German floor level. Okay, so you have your fill. You may feel that what do you call it, that the block in the foundation level, there is a filling on that. So this cross section is just explaining everything that you have at the foundation level. Okay, this is just explaining all that you have. You can make it more detailed. Okay, so you can see here telling us BRC mesh reference A147142 top. That is this BRC mesh 142. That's the BRC mesh. Okay, so this is the cross section, and then the depth of the foundation dependent on site condition. But you can see here 1,500 minimum. But from our design we did in the Prota structure, when you specify the depth of your foundation, you must have included the depth of that foundation from Prota structure. Okay, so that depth of foundation that you specify while you were analyzing and doing your design is the depth of the foundation you specify here. Okay, so you specify that this is for the T here. Let me look for this. I think this will soon be, this section will soon end, I think in less than 6 minutes. So this is the cross section T here. Let me look for anyone that looks like a T shape. Okay, this looks like T. Okay, if you cut this, you are looking at here, you are looking here. This is the shape you see in form of a T. That is what we have here. This is in form of a T. When you cut this section, you are going to see this way. You are going to see this way. It's going to look in form of an L. Okay, because when you cut here, you are definitely not seeing this particular area. This is just what you will see and here. Okay, so it's going to be in form of a T shape. So cross section is another challenge most people have. So you must understand cross sectioning while you were doing probably technical drawing and the likes. Okay, you must have done a whole lot of cross sectioning then. Okay, so when you cut that, this is what you see. So this is the cross section 2-2, an L shape, cross section 1-1 in form of a T shape. So this is how your foundation layout is going to look like for this particular design, assuming we are using AutoCAD to do our detailing manually. So I will name it foundation layout. So as it is, we are done with our foundation layout. So in our next meeting, we will go into column detail, base detail and column detail, where you are going to see how to draw this reinforcement in your base, and then how to specify the spacing of that base, and then how to come about the cross section of this base. So I'm going to be explaining all of that in our next meeting. Okay, then I will explain that of your column detail as well, and the cross section of our detail. You can see from here, we are using a continuous column because it's continuous. We don't have any short column in our design here, because all that we have in our ground floor is the same as what we have in our first floor. In the ground floor here, this place is going to be your normal veranda. Okay, then in the first floor there is going to be balcony. That is the architectural terms. Okay, so at the ground floor level is your veranda. When it's at the top, your veranda at the top is called the balcony. So, and it's actually our cantilever up there, because so I'm going to be explaining all of that in the next class. Okay.